All right. So, what we're going to do today is I'll do a brief review of the chapters and types of questions that may show up on your test on Wednesday. Um, the test will be similar to the other two, 22 multiple choice questions. But I'll give you some more details in a minute. Your final exam will be a week from today. And I believe the times are, I'll confirm it and send you an email, but I believe it's from 2:45 to 4:45 next Monday. That's your final exam. Now, the final exam will have two parts to it. First part is the core piece, where you will have to actually write down the answers. And I think the way I'm going to do it is have you, I'm going to create a separate, like a part one test, final test in Canvas, and for that one, you will actually type in your answers. One thing that I will do, I think on Friday, I will create I will record something, which I'll post in Canvas, which will explain how to enter answers in Canvas for that part one. All right, so show you some of the features of Canvas where you can put symbols in and things like that. But I think it'll be easier if I just pre-record that and post it on Canvas, okay? And I'll give you more, some more details about the final during that recording. So I'll try to do that on Friday. So part one will be, for the final next Monday, will be an hour, approximately an hour spent on the core piece. And then the second part will be a shorter than your regular test, shorter multiple choice. It's not shorter, it would be quicker. If I give you approximately the same number of questions, which is possible, then it'll be much quicker questions to do that you can get done in like a minute or so, minute or 2 minutes. So that's the schedule. So quiz number 9 is today. I have it scheduled to start around 2:40, and it'll also be half an hour, just like the last one. It'll consist of the first 4 fill in the blank statements, same as you're used to, with a stat key chart that'll be displayed each of those 4 questions. And then question 5 will be something a little different. I do a matching problem. I'll give you 4 phrases. Then there's a pull down menu for each one. You just pull down the menu and you choose that which matches that, or an answer to that particular statement. All right, so you probably have done that before. Okay, so that's that will be quiz number 9 today. And again, it'll last half an hour. Give you a little extra time on this one because of the fact that you have these charts to look at. All right, so let's talk a little bit about the test. The test will cover, in terms of full chapters in your textbook, it would be chapters 14, 16, 17, 19. Those are the full chapters. And then as far as sections are concerned, and what I'll do, I think, is maybe I will post later tonight, and email to you to let you know the sections that I'm referring to now. In addition to those chapters, sections 20, in chapter 20, that would be section 1 and 2, chapter 20. And in chapter 22, sections 1, 2, and 4. Now, there will be some things in those sections that you would not be responsible for if there's any formulas in there. But the basic ideas of hypothesis testing are in, or in confidence intervals are in those chapters. So, and do remember, I do have that video I pre-recorded the day before Thanksgiving, which gives you a nice introduction to hypothesis testing. Make sure you review the videos and all of that, and know where in the textbook everything is. All right, so in the syllabus, there's mentions of chapter 13, chapter 15. In my view, they're more supplementary because I'm not covering some of that. It talks about using contingency tables, doing significance tests with those, and to me, that's an advanced topic beyond the scope of this course, so I did not cover that in this course, and so you're not responsible for it. Chapter 15, that's mentioned in your syllabus, is sort of an introduction to randomization, simulation through computers, and you can read through that, but it's not something that we're going to be doing, except in StatKey, and StatKey sort of takes care of the simulation for you, so there's no need to read that unless you want to. All right, so once again, I will send you an email to remind you about the test on Wednesday, and also to mention the chapters again, and then those particular sections of the textbook that you should focus your attention on. Now, let me just talk a little bit about the longer chapters, because I believe you probably already know what I'll be covering in confidence intervals and hypothesis tests, because it'll be either I'll give you a chart from StatKey, either for a confidence interval for a hypothesis test, and I'll ask questions about that. And the way I'm going to ask questions, I believe, if I do show you one of those charts, is I'll give you two statements. And the statements are either going to be true or they're going to be false. And the answers to the questions for each one of those, if I do show you one of those StatKey charts, will be neither of the two are true, both of them are true, and the other two answers is that one of them is true. So one, maybe if it's if the two statements are A and B, it's A and B is and B, excuse me, A is true and B is false, or B is true and A is false. So those are the four answers that are possible. So you have to evaluate both of them for their truthfulness, and then look in the answer key and pick the correct one. All right, so that's the way I think I will do those charts, those hypotheses, those confidence intervals and hypothesis test charts. Now, if I ask you a separate question, it's not involved with StatKey, then that would be something else. All right, so let's go back to, this seems a bit long ago, but let's go back to chapter 14. Chapter 14 was about probability and long-term expectations. And so this chapter gave us an understanding of the difference between two types of probability, the relative frequency approach, personal probability approach. So you should definitely review. This is chapter 14, starts on page 306. And just go through those definitions just to make sure that you're comfortable with what they mean. There's also in this chapter 4 rules of calculating probabilities. All right, there's the rule about that if you have two possible outcomes, then the probabilities must add up to 1. That's rule 1. Rule 2 talks about if two outcomes cannot occur simultaneously, they are said to be mutually exclusive, which leads to the addition rule, where if we want to take the sum of the probabilities of two events, it would be the sum of their individual probabilities if they are mutually exclusive. Rule 3 says, if two events don't influence each other, in other words, one event does not change the probability of another event, then they're said to be independent of one another. And then you can use the multiplication rule. All right. And the multiplication rule would basically say something like, what's the probability of event A and event B occurring? And you would multiply their probabilities. And rule 4 had something to do with the idea that the probability of a subset of an event has to be less than or equal to the probability of an event. And that's rule number 4. So I could ask you to do a probability calculation based on any of those rules, or maybe a combination of those rules. And then there's also in a chapter problems where they talk about long-term expectations, maybe the expected gain or loss from a certain game, a certain type of situation. So you certainly need to look over that. There could be a problem using that. And of course, I did go over all of these things in class. So, but I'm not going to ask you anything that I did not go over in class in terms of those rules. Obviously, I'm not going to introduce new rules in a test. So just make sure that you review what's in that chapter, and you should be okay. Then chapter 16, so we're skipping 15, which is the simulation chapter. We go into chapter 16, where talking about the psychological influences on personal probability, the types of things that could distort your take on a personal probability. And so this is the chapter where they have all these different types of effects, such as the certainty effect, and there's a, what else is in here? Anchoring, availability, heuristic. You should know the definition of heuristic. There's representativeness, heuristic. All of these things I could ask questions about. Just make sure that you tag where these things are in your book, or have some notes next to you where you have the page numbers of where these things are in case you're not sure. There's also conservatism, overconfidence, things like that. So those are mostly definition type questions in that chapter. Chapter 16. Chapter 17 talks about when intuition differs from relative frequency, gives the definition of a coincidence, one type of thing. There's also the birthday problem that I went over with you in class. There's also something that could show up on your test, the gambler's fallacy and the belief in the law of small numbers. Remember, there is a law of large numbers, which is something that works, but sometimes people, like gamblers, use an incorrect belief called the belief in small numbers. Again, you may want to look at that. Something called the confusion of the inverse that's in here. And also it talks about the probability of false positives. That's a subject that's also mentioned in chapter 22. I think it's 22, section 4, which is part of the something that I asked you to review today for the quiz. So the probability of false positives is mentioned in here. And that's about it. That's chapter 17. And then we're skipping chapter 18, we're going to chapter 19. Chapter 19 is an important chapter. It's a chapter on sampling. The idea of the diversity of sample statistics from one sample to the next from the same population. So this is obviously an important chapter for what's developed later in confidence intervals and hypothesis tests. In this chapter, they do have certain conditions in which the rule for sample proportions applies. So you need to look at that, the idea of a random sample, and there exists an actual population with a fixed proportion, things like that. That's on page 411, so you should know those conditions. There is, on page 412, a calculation. This is for the standard deviation of a frequency curve for a proportion, for proportions, as it's the square root of the true proportion times 1 minus the true proportion divided by the sample size. Now, normally we use that in formulas to calculate things like confidence intervals and to do hypothesis tests. So we're not using these formulas in this course. We're using Stackey and we're using bootstrap confidence intervals and randomization, which do not use formulas. However, I would strongly recommend that you do know on page 413 what they talk about in terms of the bell-shaped curve, the probabilities of a bell-shaped curve. That is, there is a 68% chance that a sample proportion is between two values, which is plus or minus 1 standard deviation from the mean, and 95% that the sample proportion is between two other values, which are plus or minus 2 standard deviations from the mean. And then it says it's almost certain, which is 99% probability that a sample proportion is between two values. That's plus or minus 3 standard deviations from the mean. So you may want to look at that example. It's example 19.6. It starts on page 412 and goes into page 413. That is something I could ask. To calculate that standard deviation, you would, whatever proportion I give you, you would just put it inside the square root formula that they mention on that on page 412. So page 412, you would use that formula to calculate the standard deviation, and then you would add and subtract it from the mean to get your these intervals that have either a 68% chance of happening and 95% chance of happening, or it says here almost certain, which means a 99.7% chance of happening. Then on page 415, there's the rule for sample means, all right, which you should be familiar with, even though, again, we don't use it for confidence intervals and hypothesis tests. It would be good for you to know that rule. It's on page 415. All right, and it gives you a formula on page 416 of the standard deviation or the frequency curve of means, where you take the population standard deviation and divide it by the square root of the sample size. And once again, once you have that standard deviation, you can add and subtract it from the sample mean to get these probabilities: 68% plus or minus 1 standard deviation from the mean, 95% plus or minus 2 standard deviations from the mean, and it says, again, almost certain, which is a 99.7% from the chance from the mean, which is plus or minus 3 standard deviations. This is all on pages 416 and 417. So you could look at that also. It's not a hard calculation to do on your calculator, so it's something I refer to. All right. See if there's anything else in here that I would possibly ask. That would be it. So just look for those rules that I talked about. By the way, in chapter 19, they do talk about, they give a brief definition of both confidence intervals and a hypothesis test on page 417 and 418. You may want to look at that just as a brief introduction. But again, my lectures and my videos should all cover that in more detail. All right. And that's it for those chapters. All right. Now, for the confidence intervals, most likely I'm going to ask 4 questions on the test, and not sure if every question will have a StatKey bootstrap confidence interval that I'll be displaying. It's possible that maybe one won't. So I would say at least 3 of them probably will have those charts in them. And again, if they do have the charts, I will give you 2 statements about the charts, and then I'll ask you which ones are true. And again, it could be both of them are true, neither one of them is true, or one of them is true for those 4 possible answers. And so as far as StatKey is concerned, for the bootstrap, just make sure that you understand that the sample proportion, all the bootstrap samples are being derived from that original sample proportion or sample mean. And by the way, there are 4 different types of confidence intervals. There's a confidence interval for one mean, where you're adding, where the bootstrap distribution comes up with its confidence interval. You can have a confidence interval for a one proportion, or a difference in means, or difference in proportions. So if it's a difference of means, there's group 1 and group 2. Typically, for means, it would be the population mean, mu1 minus mu2, would be the difference in their means. So if for example, the difference in means is positive, that means group 1's mean is bigger than group 2's mean. Hope that makes sense to you. If you're subtracting two means, and if the difference is positive, that means the first group is bigger than the second group's mean. And then if the difference in their means is negative, that means group 2's mean is bigger than group 1's. All right. So in terms of interpretation, all of that, I think it's hopefully common sense to you that that's what it would be. So they're treated, no different. And then doing one mean or one proportion, you can have a difference in means or difference in proportions. But know that the confidence intervals are all derived from the original sample mean. And there is a confidence level, which is determined by that middle number it's right in the middle of the chart, right? The confidence level, it could say 0.95, 0.99, 0.90, or anything else, basically. All right, so that's your confidence interval. And how would you figure out how many bootstrap samples are inside that interval? It would be, if it's a 95% confidence interval, and it would be 0.95 times the number of bootstrap samples, all the dots, and that would give you the number of black dots in the middle. And then the number that are outside that interval would just be all the red dots that are there. And that's easy to calculate, because it's literally the total number of dots minus the number of dots in the middle. We give you the number of red dots. So, remember with confidence intervals, this is very important. Confidence intervals are not probabilities. If I say a 95% confidence interval, and I give you the interval, it does not mean, and I'll underline the word not, it does not mean that there's a 95% probability that the true population mean is in that particular interval. It does not mean that. Because any confidence interval from any sample mean that you could draw from the population, they'll all be different intervals. So to say that in one particular interval, that interval contains the true population mean is incorrect. What the 95% is saying is that you're 95% confident that out of all the possible sample means and confidence intervals that are created from those sample means, 95% of them will contain the true population mean, and you're hoping that that particular one that you've chosen is one of the 95% and not one of the 5% that does not contain population mean. So that's what it means. That's what it means. It does not mean there's a probability. It's a probability, right? So you have to be really sure about that, because I will certainly ask that question in the test, something like that in there. Okay, and then hypothesis tests. There are, again, 4 types of hypothesis tests in terms of for single mean, for single proportion, for difference in means, for difference in proportions. All right. But remember, in a hypothesis test, there is a null hypothesis. So for a single mean, it would be mu, the Greek letter mu is equal to some number. Right? It's usually in the stat key chart. It's towards the top. You'll see it'll say null hypothesis. That's the null value. It's going to always be equal to, and if it's a mean. And then the alternative hypothesis is one of 3 possibilities. All right, and be very careful with this. It's either less than, greater than, or not equal to. And that is typically stated in the problem. The problem itself will state whether the researcher, that's trying to show that the null hypothesis is false, the researcher comes up with a competing hypothesis, and they will say, I think it's less than this value. Or they'll say, I think it's more than this value. Or they'll just say, I think it's different from this value. So if it's less than this value, you do your left tail test. You check off the left tail box in StatKey. If it's a right tail test, you check off the right box. So if it's a left tail test, let me just say it again, a left tail test, it means the alternative hypothesis is mu is less than some number. And you have to make sure that number is the same number as in the null hypothesis. All right, those numbers must match. If it's a right tail test, the alternative hypothesis says greater than, mu is greater than the same number. Or if it's a two tail hypothesis test, it'll say not equal to. All right, not equal to. So those are the three choices based on the particular problem. Right, those are the three types of tests. Now, in any StatKey hypothesis test chart that I show you, I will state that the sample mean has already been entered into one of the lower boxes in the StatKey chart where typically the values are. So I've already entered it in there. If it's a two-tail test, you may not know which of the two boxes I've entered the true mean in, but I won't ask about that. Just assume it's one of those two boxes. For the left or right tail test, is there's just one box there. I've already entered the sample mean in there, so you know what it is. All right. What else? Now, if I've entered the sample mean in there, then if it's a left tail test or a right tail test, then the box to the left or box to the right in the StatKey chart is going to be the p-value, right? If it's a left tail test, you see the box towards the left in the middle where the distribution is. You'll see a box in there, and it'll give a decimal, and that's the p-value. Same thing with the right tail test, except the box will be to the right of the mean, and that, in the middle, and that's the p-value. All right. If you have a two-tail test, you have to make sure that you add. There'll be two boxes in the middle of the chart. You add the two decimals together to get the full p-value. Make sure you do that. If you don't do it, you'll get wrong answers. Okay, and then the rule is, if the p-value is less than alpha, which is the level of significance, the probability of a type 1 error, they all mean the same thing. P-value is less than or equal to alpha, we reject the null hypothesis, and we support the alternative hypothesis. So we say there's enough evidence to reject the null hypothesis and support the alternative hypothesis. It does not mean, all right, let me say it one other possibility. If the p-value is greater than alpha, then we do not reject the null hypothesis. All right. Now, when we do not reject the null hypothesis, doesn't mean that we accept the null hypothesis is true. That's because the null hypothesis can still be false. It's just that for that particular sample, there was not enough evidence to reject the null hypothesis. So if the p-value is greater than alpha, we do not reject the null hypothesis. So it's important to know that rule, all right? Not only for the test on Wednesday, but for today's quiz too. It's important to know that rule, all right? What else about hypothesis tests? Well, you should obviously also know about the types of errors that you can have in hypothesis tests. The type 1 error would be when you reject the null hypothesis, statistically reject it with the test, but in reality, the null hypothesis is actually true. So that's an error, and that's called the type 1 error. The probability of a type 1 error is alpha. or the level of significance. Okay, so alpha, or the level of significance, or the probability of a type 1 error, all mean the same thing. And that's the probability of rejecting the null hypothesis through a statistical test, when in reality the null hypothesis is true. The other thing that you should know is the type 2 error. This occurs when you do not have enough evidence to reject the null hypothesis. You do not reject the null, when the null hypothesis is actually false. That's called a type 2 error. And the probability of that is called beta. It's a Greek letter beta. Now, we don't really work with the probability of type 2 error too much in this course. It's something that people tend to work on more in maybe a second semester or second year course in statistics. But you should know what it is. You should know what it means. It's important to know what it means. So it's a probability. So a type 2 error is when you do not reject the null hypothesis, when the null hypothesis is false, and the probability of that is called beta. And finally, the last thing, and this is again on chapter 22, section 4, those pages that I asked you to review before today's quiz, there is what's called the power of the test. Again, an advanced topic for other courses, but in terms of definition, easy enough for you to know for this course. And the power of the test is basically the probability of rejecting the null hypothesis when it's actually false. In other words, it's a correct decision, and it's called the power of the test because the person who is performing the test, the researcher, is hoping to reject the null hypothesis and is hoping that the null hypothesis is actually false. So they want that to happen. So that's called the power of the test. It is expressed, the probability, its probability is expressed just like any other probability from 0 to 1. All right, but in terms of this course, that's all that you need to know. Is the definition of the power of the test. All right, are there any questions? Because that's pretty much it for the review. There's about 2.5 minutes left for the quiz. All right, so again, it's open book. You have access to the book, your own notes, anything that I posted in Canvas. You can print out and have that next to you also. Make sure you have a calculator next to you. That's important. Calculator. Make sure the calculator can do square roots and all that sort of thing. So you can use Excel. You can use Google Sheets. Anything like that. The only thing I ask you not to use is somebody else's help. That's not right. You should not be doing that. All right. All right, so make sure now, we only have 2 minutes left, that you've turned your videos on so that I can see you and see what you're doing. So your videos need to be turned on, please. Okay, thank you. All right, so let's just, since there's nothing else. And again, in terms of the final, I will do that video. It won't be that long. It'll be hopefully no more than half an hour, the video. I'll do it on Friday, both your class and the other class that I have in Stat Literacy. And it will review how to enter questions, how to use Canvas when you're answering questions. It's sort of like in essay mode, but there will be, there's functions in there where you can put symbols and things like that. So I will show you how to do that and how to do that in Canvas for that first part of the final exam next week. All right, so if there's no questions, I'm going to stop the recording.